In today's episode, there's a storm of developments across the globe. China has just unveiled a bold new plan to explore the solar system, one that spans from Venus to Neptune. At the same time, NASA has made an exciting discovery on Mars, while ESA pushes forward with its own mission to land humans on the Red Planet. And over in Europe, their first rocket ended up making an unexpected return to the launch site. So there's a lot going on, but the most jaw-dropping development comes from China, and it's not just ambitious, some parts of it sound absolutely insane. China's making moves with a new organization called the Deep Space Exploration Laboratory. The purpose of this lab is to strengthen China's ability to explore deep space across the solar system. It's a partnership between the China National Space Administration and the University of Science and Technology of China. And this isn't just a flashy announcement. China has the credentials to back it up. They've already achieved major milestones like landing the first rover on the far side of the moon and completing a successful lunar sample return. Plus, they're only the second country after the US to operate a rover on Mars. Here's what's coming. In 2028, China plans to launch the Tianwen-3 mission to Mars. This mission aims to collect soil and rock samples and return them directly to Earth. This mission was already known, but it's great to hear the timeline is still intact. If it succeeds, it would become the first Mars sample return mission in history, unless, of course, Elon Musk manages to beat them to it with a Starship. Then in 2029, China plans Tianwen-4, a mission to Jupiter and its moon Callisto. This is something they've hinted at before, but now it seems locked in with real planning behind it. This 2029 mission is particularly interesting because it'll operate in tandem with NASA's Europa Clipper and Europe's JUICE probe. Those missions will be exploring Europa and Ganymede, respectively, so Tianwen-4 rounds out the trio by focusing on Callisto. That leaves only Io unstudied among the four big Jovian moons. In 2030, the action comes back to Earth. China plans to build a large, ground-based habitat that can simulate long-duration human spaceflight. It's basically going to be a Mars and Moon-based simulator, testing how humans can live in extreme, isolated conditions for extended periods. Then in 2033, China plans to send a mission to Venus. But this isn't just a flyby or orbiter, they want to return samples from Venus' atmosphere to Earth. That's wild. Depending on how far down they go into the planet's thick, toxic atmosphere, it could involve using a glider or a floating balloon probe. That would suck in gases, analyze them, then somehow fire a return capsule back into orbit. It's the first time we've heard of a serious attempt to bring Venus atmosphere samples back to Earth. That alone is a huge technological leap. By 2038, they're planning to establish an autonomous research station on Mars. The goal of this mission will be to study how to use local Martian resources to support human life, what's known as in situ resource utilization. This robotic Mars base would likely mirror their plans for a similar international lunar research station they want to build on the Moon. If successful, it would pave the way for sustainable human missions, creating a base that could eventually support astronauts. And finally, in 2039, China wants to send a mission to Triton, Neptune's largest moon. This mission includes a plan to deploy a subsurface explorer. That means they want to send a robotic probe that could drill, or melt, its way through Triton's icy shell and reach the salty ocean believed to exist below. It's a concept similar to what's been proposed for Jupiter's Europa, but with one big difference. Triton is much farther away. That adds massive challenges in terms of communication, propulsion, and power. To pull off a subsurface mission like this, China would likely need a nuclear-powered spacecraft. That's not as far-fetched as it used to sound. By 2039, advances in compact nuclear tech may make such missions possible, even practical for the outer planets. So yeah, China's deep space roadmap is nothing short of stunning. They're proposing a timeline that touches almost every major body in our solar system, and they're backing it with growing capability and credibility. It also comes at a time when NASA is facing real uncertainty. There are budget cuts looming, the agency still has no confirmed leader, the Artemis moon mission keeps slipping, and their own Mars sample return program is being held together by international and private partnerships. Despite that, NASA is still doing incredible science, especially on Mars, and their latest discovery might just blow your mind. That brings us to the Curiosity rover. It's one of two rovers currently active on Mars, and although it was launched way back in 2011, it's still going strong. This six-wheeled nuclear-powered robot is about the size of a car, and it's made a surprising discovery. Inside a Martian rock, Curiosity has found the largest organic molecules ever detected on the planet. But don't get ahead of yourself, organic doesn't automatically mean alien life. In scientific terms, An organic molecule is any molecule that contains carbon, which is the basic building block of life as we know it. These particular molecules are known as long-chain carbon compounds, meaning they're made up of many atoms strung together in a sequence. That structure is significant because, on Earth, long-chain carbon molecules are usually associated with living organisms. Specifically, the molecules found might be fragments of fatty acids, the kinds of compounds you find in cell membranes. If there's any kind of life to be found on Mars, it would most likely be microbial. Mars probably didn't stay habitable long enough to support the evolution of complex life. But even detecting ancient microbes would be a massive scientific milestone. And here's the problem. Microbes are incredibly small and very hard to detect with absolute certainty. That's why we need to bring samples back to Earth. Curiosity's instruments are powerful, but not powerful enough to give us a definitive answer. The molecules it found came from a rock called Cumberland, located in what used to be a lake bed inside Gale Crater. This rock is estimated to be 3.7 billion years old. Scientists are now analyzing the molecules in detail. They're not just made of carbon but also hydrogen and oxygen, elements that can combine in many ways to form life-related structures. In today's episode, we're diving into a whirlwind of groundbreaking updates from the world of space exploration. China has just unveiled an incredibly bold and far-reaching roadmap to explore our solar system, and the scope of their ambition is staggering, from the scorching clouds of Venus all the way out to the icy moon of Neptune. At the same time, NASA continues to make headlines with new discoveries on the Martian surface, while the European Space Agency is attempting to rewrite its Mars legacy with a high-stakes mission. And to top it off, a small European rocket startup had a dramatic first launch, ending not in space, but in a fiery splashdown near the launch pad. Let's break it all down. China's latest space initiative is not just another series of missions. It's a coordinated campaign that spans the entire solar system. Spearheaded by a newly established organization called the Deep Space Exploration Laboratory, this entity represents a partnership between China's National Space Administration and the University of Science and Technology of China. The lab's mission is straightforward but ambitious: expand and deepen China's ability to explore space. China's track record is nothing to scoff at either. They've already made history as the first country to land and operate a rover on the moon's far side and became the second nation after the United States to land and drive a rover on Mars. So, they're not exactly amateurs. Let's talk details. The first big step in this roadmap arrives in 2028 with the Tianwen-3 mission, which will attempt to collect Martian soil and rock samples and return them directly to Earth. It's a mission we've heard about before, but seeing it still firmly in China's long-term plan adds confidence that it's moving ahead. If successful, it would mark the first-ever Mars sample return mission, unless, of course, Elon Musk and SpaceX manage to beat them to it using Starship. The following year, in 2029, China plans to launch Tianwen-4, aimed at exploring Jupiter and its moon Callisto. This aligns with NASA's Clipper mission focused on Europa and Europe's JUICE mission targeting Ganymede. With all three major Jovian moons being covered, it leaves Io as the only major Galilean moon without a planned close-up study, for now. By 2030, the focus turns inward. China plans to build a large ground-based habitat on Earth designed to simulate long-duration space missions, particularly to Mars or the Moon. Think of it like a practice Mars base, where everything from daily routines to emergency procedures can be stress-tested without leaving Earth's atmosphere. In 2033, they aim to go where few have dared, Venus. But this time, not just to orbit or scan from afar. China wants to conduct a sample return from Venus's atmosphere, a first of its kind. Depending on how deep into the atmosphere they go, it could involve technologies like gliders or balloons to collect atmospheric gases and then fire a propulsion system to return the sample to orbit. It's the kind of mission that sounds almost science fiction, yet it's in their official timeline. Moving ahead to 2038, China wants to establish an autonomous Mars research station. This wouldn't just be a few landers and rovers. It's essentially a robotic Mars base capable of studying in-situ resource utilization, such as extracting water or producing oxygen. The idea is similar to their International Lunar Research Station concept and aims to lay groundwork for future human exploration. And then comes 2039, a mission that's arguably the most ambitious of all. They want to send a spacecraft to Neptune's moon Triton, which may harbor a subsurface ocean beneath its icy crust. The mission would potentially include a probe capable of drilling or melting through the ice to explore what lies beneath. An ambitious task, especially given the distance and the engineering challenges involved. It's only feasible if propulsion technology takes a massive leap forward, possibly through nuclear power systems. This expansive roadmap comes at a time when NASA is facing significant headwinds. Budget cuts loom, leadership remains uncertain, and the Artemis lunar program is stumbling. NASA's own Mars sample return mission is in limbo, currently being redesigned with help from international partners and private companies. Still, despite these hurdles, NASA continues to conduct critical work, especially on Mars. The Curiosity rover, which launched all the way back in 2011, is still hard at work, and its latest discovery has scientists excited. This nuclear-powered, six-wheeled rover, roughly the size of a mid-sized SUV, has found something strange inside a Martian rock: organic molecules. Specifically, the largest ever detected on the red planet. Now, before we jump to conclusions, it's important to clarify, organic doesn't automatically mean life. An organic molecule is simply one that contains carbon atoms, the chemical backbone of life as we know it. What makes this discovery special is that these are long-chain carbon molecules, meaning many atoms are bonded together in a structure that's complex enough to resemble the kinds of molecules associated with biology here on Earth. The molecules found may be fragments of fatty acids, the same kinds that form the membranes of biological cells. That's a big deal. If life ever existed on Mars, it likely would have been microbial, and evidence of such life would be microscopic and difficult to detect with current rover equipment. That's why sample return missions, like Tianwen-3 or NASA's planned return program, are so crucial. Earth-based laboratories have much more powerful tools that could provide clearer answers about Martian biology. The organic molecules Curiosity discovered came from a rock known as Cumberland, located in an ancient lake bed inside the Gale crater. That rock is about 3.7 billion years old, dating back to a time when Mars may have supported liquid water. Scientists are hoping that, by analyzing these molecules in more detail, they might eventually discover amino acids, the building blocks of proteins and, by extension, of life itself. Even though we're not there yet, long-chain hydrocarbon molecules like the ones Curiosity found are a step in the right direction. Among these molecules, researchers identified decane, which contains 10 carbon atoms and 22 hydrogen atoms, and dodecane with 12 carbon atoms and 26 hydrogen atoms. These belong to a group of chemicals known as alkanes, which are simple types of hydrocarbons. On Earth, such molecules can be found in petroleum and biological matter, so their presence on Mars is tantalizing. Discoveries like these keep fueling our obsession with the red planet and drive missions like those we discussed earlier from China. But it's not just China and the US making headlines. Europe is gearing up for another high-stakes attempt at Mars exploration through its long-delayed ExoMars program. ExoMars is the European Space Agency's third attempt to land on Mars. Their 2016 Schiaparelli lander crashed due to a computer glitch. Before that, in 2003, the Beagle 2 lander did make it to the surface, but its solar panels failed to deploy, leaving it unable to communicate with Earth. So, the pressure is on this time. And with a $1.3 billion price tag and over 2 decades of development, the stakes couldn't be higher. Originally, ExoMars was scheduled to launch on a Russian Soyuz rocket back in 2011, but delays and shifting international partnerships kept pushing it back. At one point, the mission was supposed to be a joint venture between Europe and Russia, but given recent events, that partnership is no longer viable. Fortunately, there's been a breakthrough. The French aerospace giant Airbus has stepped in to replace Russia as the builder of the ExoMars landing platform. This critical component handles the spacecraft's final descent to the Martian surface and will deploy ramps for the Rosalind Franklin rover to begin its mission. However, Europe still faces a transportation issue. They currently don't have a rocket powerful enough to launch ExoMars independently. That's where NASA comes in again, offering not just a launch vehicle but also the descent module's engine and radioactive heating units essential for surviving Martian nights. The launch vehicle hasn't been finalized, but possibilities include SpaceX's Falcon Heavy, ULA's Vulcan, or Blue Origin's upcoming New Glenn rocket. The tentative launch window is set for December 2028, unless, of course, Elon surprises everyone with a fleet of starships ready to go. And while Europe is betting big on Mars, they're also testing the waters with their own rocket startups. A small aerospace company named ESAR Aerospace has been working on its Spectrum rocket, a launcher designed for small satellites. After years of preparation, ESAR finally got the green light to launch from Andøya Spaceport in Norway, marking the first orbital attempt from mainland Europe outside Russia. Things were looking promising, until about 30 seconds into the flight. The rocket began a planned maneuver to tilt its trajectory horizontally, but it all went terribly wrong. The rocket quickly lost stability, wobbling erratically before flipping upside down and nosediving back toward the Norwegian coast. It crashed into the icy waters nearby in a fiery explosion. The broadcast cut off and so did the mission. It wasn't exactly the debut Isar Aerospace was hoping for. However, shortly afterward, company officials addressed the failure. While they didn't provide many technical specifics, they did confirm that the onboard flight termination system was triggered in response to the wobble. Rather than detonating the rocket as is usually the case, the system shut down all 9 of its Aquila engines, leading to the rocket's unexpected return to Earth in one piece, albeit not intact. Interestingly, this event didn't destroy the launch pad, which is rare and something the company considers a silver lining. It means they can begin working on the next test flight without major delays. In fact, despite the crash, Isar officials called the mission a partial success, citing the wealth of data collected and the intact launch infrastructure. Still, questions remain about what went wrong during the pitch maneuver and whether Spectrum will be able to prove itself in a competitive small satellite launch market dominated by companies like Rocket Lab and SpaceX. For now, Europe has dipped its toe into independent spaceflight, and while the result wasn't perfect, the journey is just beginning.